Hi, good morning. I'll wait for everyone to get your headsets on. Welcome to day 3 of reInvent. I hope you are pacing yourselves, that you're well rested, you're well caffeinated, and ready to talk about open source software. Specifically today, we're going to be talking about some of the interesting things coming in Apache ActiveMQ. ActiveMQ is one of the most widely used message brokers, open source message brokers today, and something that we at Amazon are really involved in the development of. My name is Jules Grable. I lead messaging services for AWS. That includes the Amazon MQ service. That's a managed service for open source message brokers, including ActiveMQ and RabbitMQ. I'm joined today on stage by, I'm going to be honest, this is exciting for me, one of my open source role models, JB Onofre, from the Apache Software Foundation.
So, good morning, everyone. I'm JB, board member of the Apache Software Foundation. I'm working roughly on 20-25 Apache projects as PMC member, including ActiveMQ. So, before doing a deep dive into ActiveMQ 6 and 7 and so on, it's important to remember what ActiveMQ is. So Jules said is a message broker. So what is a message broker actually? So if we take a look about a message broker, there are different characteristics of a message broker. But the most important to me is the split between the producer and the consumer. This split gives us a lot of different use cases. The producer of a message never knows where the consumer is located and who is the consumer. He just knows one entity, one destination into the broker. And on the other hand, the consumer, he doesn't know where the message is coming from. So we have a kind of man in the middle pattern by a message broker. And why it's a broker, not a client server? Because inside the broker, we can apply some kind of advanced features on the messages. So we can apply message routing. So we get a message on one destination, a queue or topic, and we can route this message to another destination, another queue, another topic, like a composite destination. I receive from one queue, I can forward to a set of queues. So that's what ActiveMQ is a broker. It's not just a message server, because we can apply logic like that. We can also have buffering. So buffering is basically what we name asynchronous delivery. We accumulate messages into the broker to give consumers a way to consume messages. And depending if we are on a queue or on a topic, we're going to have different ways to consume. One too many or many too many, it depends a lot of the destination you are using. The same as routing, you can do filtering. Okay, this message, I don't want to deliver to anyone. So this message is basically lost. Or this message is only delivered if an header of this message is like this. So it's what we call selectors. When you consume the message you want, you implement selectors. That's basically the filtering. And finally, in my opinion, one of the main use cases and the most important use case in ActiveMQ is all about transaction. Thanks to all the acknowledge on the production side, but also on the consumption side, you can consider your broker as a transaction resource. Like, okay, I produce a message, and I know that when this message has been produced, I know it has been delivered to the broker, and the broker is able to deal with. If it's not delivered for any reason, then my client knows, and I can try another time, I can send another message. It's really up to me. So you can consider the broker as a transaction resource. And so this is the general features about a message broker. So now let's go into ActiveMQ. What is ActiveMQ as a message broker? The first thing is based on standards. Could be Java standard like JMS. It could be more de facto standard like AMQP, MQTT. So everything in ActiveMQ is based on standard. We implemented the specifications, basically. It's a message runtime. So in ActiveMQ, you have basically two parts. The broker part. So you can just run the broker on your machine. You just run ActiveMQ and you have a broker ready to be used. But we also provide the client part. So the client part could be only the ActiveMQ connection factory if you are using JMS, and then you are just using JMS APIs. Or it could be more advanced kind of client, depending when you want to do Stomp, for instance, Stomp protocol, when you want to use ActiveMQ with Python or Rust or stuff like that. So we also provide this kind of clients. It's multi-transport. So the way we communicate between the clients and the broker, or between brokers, because we can also implement network connection between brokers. It's not defined. I mean, you can use a bunch of different protocols. You can use VM, for instance. So it means that you can embed ActiveMQ in your applications and deliver the message directly using the JVM, not using the network. So it's very convenient because with that, you can have a kind of disconnect connection between some clients and the broker. I have a bunch of examples that I can share after the talk if you want about this use case. TCP and SSL, that's mostly what you're going to use to communicate between your client and the brokers. You can also support HTTP and WebSocket. So Stomp is basically based a little on WebSocket. It's multi-platform. It means that the broker just needs a JVM. So there are no native code in ActiveMQ broker. So in any machine where you have a JVM, you can directly run ActiveMQ and you have a broker ready to run. It's multi-client, so multi-client in terms of language. So even if you are using Java, C, C#, C++, whatever, you have a client ready to be used with ActiveMQ. So this client could be directly provided by ActiveMQ. Is the case for NMS. NMS is basically the C client for ActiveMQ, or it could be provided in Java, so JMS, as I said, using the connection factory. So that's basically the idea about ActiveMQ and what is ActiveMQ today. If we take a look on the roadmap, I mean, not the roadmap for the future, but more the history of ActiveMQ. So ActiveMQ actually started in 2004 in a small company named LogicBlaze. At that time, we wanted to implement a JMS broker. So IBM MQ was a very popular and still is a very popular broker. And so we wanted something in open source. So we started in LogicBlaze, basically implementing the JMS API. At that time, it was 1.0 API. And then in 2005, we created ActiveMQ 3. So 1 and 2 was mostly prototypes. Not really production ready. But ActiveMQ 3 was the first version really production grade broker. This ActiveMQ 3 version has been donated to the Apache Software Foundation. So the ActiveMQ project started into the Apache incubator in 2005. This ActiveMQ 3 version includes two major changes in the broker. It was the message persistency. It was not yet KDB, for the one who knows KDB. It was before KDB. So it was a way to store the messages on the file system and secure the broker with performances, transaction, and stuff like that. Later in 2006, we created ActiveMQ 4 that is an improvement based on ActiveMQ 3 that brings new features like a message group, virtual topics, stuff like that. So it was mostly improvement in ActiveMQ 4. ActiveMQ 4 was, I think, the main version used in production. I mean, we got a lot of users enthusiasm about this version, and they started to use in production, like in financial company, in industries, stuff like that. ActiveMQ 5, in my opinion, was the big milestone in the project because it was a complete broker in terms of feature where we introduced KDB. So KDB came from all the message store we created in the past, and we wanted to have much more performant message store, and it's where we created KDB. Second thing is ActiveMQ 5 is super important for the project because it's the time where ActiveMQ moved from the incubator to a top-level project. So it became a top-level project at Apache, meaning activemq.apache.org. So it was ActiveMQ 5. It was in 2007, so it's pretty old. But we still continue to contribute on ActiveMQ, and in the past, we also had a new broker who joined the ActiveMQ top-level project, Artemis. So Artemis was the name before Artemis was OrnetMQ. OrnetMQ has been donated to the Apache Software Foundation. We discussed about different options. Maybe Artemis as a top-level project on its own, or host Artemis as part of the ActiveMQ ecosystem. So we decided to Artemis to join the ActiveMQ ecosystem. So that's why today we have basically two brokers in ActiveMQ. We have Artemis and ActiveMQ Classic. It's not a competition, it's different brokers, it's basically the same features, in my opinion. So you have a choice. You have the choice to use one or another. There are two communities, two brokers are maintained all together. And we still continue to work on it. And in 2023, so last year, we released ActiveMQ 6. That's the purpose of this talk today. What is ActiveMQ 6? So it's, in my opinion, is the same kind of milestone compared to ActiveMQ 5. It's a big jump in the ActiveMQ project. And what is ActiveMQ 6? At core is JMS2 and Jakarta messaging free compliant. That was the main focus for ActiveMQ 6. Fully support the JMS2 API because ActiveMQ 5 was JMS 1.1. Only 5.18 has a different, both support of 1.1 and 2, but the focus on ActiveMQ 6 is really about JMS2 and Jakarta messaging. But it's not only this. We also had new stuff in ActiveMQ 6. We had support of new JVM version. So you can run with JDK 17++ up to Java 23 with ActiveMQ 6. We also updated our dependencies. In the broker, we are still using Spring and Jetty internally to the ActiveMQ broker. So we upgraded to latest version of Spring and Jetty. We also upgraded to Apache Camel 4. So Apache Camel is a way to implement EIPs, Enterprise Integration Patterns, inside directly ActiveMQ. Camel 4 was the new long life release for Camel, so we upgraded into ActiveMQ. A big focus has been done also about cloud deployment for ActiveMQ. So now in ActiveMQ 6, you directly go on Docker Hub and you can get Docker images ready to run for ActiveMQ 6. It was not the case before. It was backported to ActiveMQ 5, but it was really a focus on ActiveMQ 6. And two major updates about ActiveMQ internals is about security and observability improvement. So we added new MBINs, we added new Prometheus exporter, we added new OpenTelemetry stuff inside the broker, just to give you a more detailed view about what's happening inside the broker. The purpose of ActiveMQ is not to provide a UI or dashboard or whatever, it's just to provide the metrics and the trust you need for your infrastructure to create all the dashboards they need. Same about security. We improved by providing new plugins to support new role-based access control, stuff like that. Performances, most of the performances has been focused on CarDB and transaction. So that's basically the idea. What I said, the most important is JMS2. But what is JMS2? Actually, JMS2, the first purpose of JMS2 is to simplify a lot the APIs. I mean, in JMS1, you have to do a lot of boilerplate code just to send a simple message to the broker. So this is an example of code. I have a connection factory, so let's say the ActiveMQ connection factory. Based on this connection factory, I'm creating a connection, and then on the connection, I create a session. On the session, I define my acknowledge, and then using my session, I create a producer, I create a text message, and I send my message. Wow. Super long, super complex, a lot of boilerplate code. JMS2, 2 lines. I create a JMS context. I create directly in line on this context. I create a producer, and I directly send the message, providing the message payload. Easier. And it's the same also for exception handling. Exception handling in JMS1 was super painful. The reason is mostly because JMS exception was check exception. So it means basically in your code you have to do a try catch block everywhere. Now in JMS2 it's much easier because JMS runtime exception is an unchecked exception. So basically you can catch this exception pretty quickly, pretty easily, and you don't have to do a try catch block everywhere. So that's also a huge improvement in terms of the way for you create your application logic. But it's not only, I would say, simplification. They also change a little of the API. Like now you can directly send the payload directly on when you send a message. You don't have to wrap this payload using a text message, a mat message, a byte message. That's over. Now you just do, okay, I want to send this payload. So this is an example, again, basically the same as I showed before. Like you create a producer and you directly send the payload as part of the send method. So that's again, a simplification, but it's a little change in the API. Bigger change on the API is the way you do message consumption. So there are two ways for you in your application to receive a message. You can use the .receive message method. So basically this method is blocking. You are waiting for a message to be dispatched to you, to your client, or you can use a message listener. So in JMS1, we use a message listener, which is basically an interface. And this interface forces you to implement one method, which is the onMessage method. So again, very, very complex. I mean, not in terms of logic, but in terms of boilerplate code, because you have to create this interface, implement the onMessage method extra. In JMS2 is easier because you can directly use a Lambda. So using a Lambda, you just do, okay, I create a consumer and I define set message listener and I put my Lambda there, done. So it means that the broker, ActiveMQ, will dispatch the message to your client and your application will react when a message will be dispatched to your client. But there are also some changes that happen in terms of code base. So I talk about JMS2, but now we have Jakarta messaging 3. In terms of API, basically the same. I mean, there are no big changes, but one very impactful changes for you is the namespace, because we move from javax.jms to jakarta.jms. So it means that theoretically, in your application, you have to change everywhere. So it's a little bit painful. What we did in ActiveMQ, we decided in 5.18 to support both. So it means that ActiveMQ 5.18 can receive messages from javax.jms client, but also from jakarta.jms client. It's up to you. The reason why we put that in 5.18 is simply to give you time to migrate from JMS1 to JMS2. And then now in ActiveMQ 6, we only support in Jakarta JMS because it's the new API, it's the new version. So you have to move to the new version at some point. Some things that happen also in Jakarta messaging is some kind of cleanup in terms of method you can use. So now, for instance, you can implement delivery delay on the producer. So when you produce a message, you can decide, okay, I don't send my message now. I want to send in 2 seconds or 20 milliseconds, up to you. So you can introduce delay. That's specific to JMS2 and Jakarta messaging 3. Another thing that we implemented in ActiveMQ, and the specification you use what we implemented in ActiveMQ is about asynchronous production. So now, normally, when you use the send method on a producer, it's a blocking method. So it means that your application is waiting for the acknowledge from the client, from the broker, when you produce. So now you have a method which is send async, where you basically just send, and the acknowledge handling is delegated to another thread later. So that's very convenient, and actually the throughput is way better like this. So this is all the thing we implemented in ActiveMQ 6. Mostly, so my 2 messages is JMS2 and Jakarta messaging 3. That's the big jump. But also all the JDK version extra that we implemented in ActiveMQ 6.
Thanks, JB. I'm going to switch over for a few minutes and talk about the Amazon MQ for ActiveMQ service and some of what you can do with ActiveMQ when you're running in the cloud and on AWS. The Amazon MQ for ActiveMQ service, this is a managed service for an open source product. And like with many of the managed services that AWS offers, the advantage to you as a customer is that you have a team of people who wake up every day thinking about how do we run ActiveMQ and operate it with the best practices for security, patching, reliability, robustness. And we take care of all the heavy lifting of those tasks so that you can focus on your work as a developer and your application. I thought before I jump into that, let me, quick timeline here. We launched this service in 2017, supporting ActiveMQ. In 2020, we expanded support to another popular open source message broker, RabbitMQ. You can use either on the service, and largely you have the same experience in terms of being able to provision, manage, scale your brokers. I thought that for this crowd today, it would be interesting to do a deep dive into a particularly interesting feature that we launched recently, which is cross-region data replication for ActiveMQ. So what's cross-region data replication? Basically, the name is the recipe. You have your broker, and generally you're going to have all your producers and consumer applications, your databases, everything is running in what we call a primary region. This example, US East 1. And you want to clone everything into what we call a replication region, a replica region, in this case, US West 2. So you want all of your configuration, you want all of your data, you want all of your state to be cloned and replicated to that replication region on an ongoing basis so that at some point you could conceivably move your entire workload over to a new region across the country with no loss of data or state. We support this for ActiveMQ, and you can go use it today. It's pretty simple to set up. You have a broker running, and you just request that it create a replica. The replica, we support this for North America regions right now. The replica is an exact copy of all the configuration of your broker. If it's a high availability broker with multiple nodes, we create a replica of all the nodes. And then we start migrating data. This is a warm standby replication, right? So in your replica region, US West 2, you see the little X on the line there. It means that you can't connect any producer or consumer applications directly to the replica region. You're always working within your primary region, always working within one region. We're replicating the data between the two regions, and this replication is one of the first insights that we had when we were building this feature that I think was really new for us, was we thought about how do you replicate data for a message broker? If you have a database or streaming service, there's sort of a naive view of replication, which is that you take the transaction log and you just stream the transaction log, or whatever the equivalent is for your database, to another region, and so that you can recreate all the data in a new region. But for a message broker, what you have is you have producers who are racing to enqueue messages, and then you have consumer applications that are pulling messages off of the queue and acknowledging them, and those messages get deleted when they get acknowledged. So a really well-balanced message broker might have an empty queue. And what we realized was that if we received a message into the broker and we paused for a second and waited, often that message would get consumed and deleted faster than we could replicate it to the new region. And so by creating a sliding window where we give the chance for the messages to be deleted before they're replicated, when it's tuned right, we prove to ourselves that we can actually net replicate the messages on the broker faster to another region by introducing a slight delay. So that's a feature that we added, we've implemented on the replication engine supporting this feature. Okay, so now you've got your replica region set up, you're replicating messages, everything's running great. You want to switch over to your new region. We support 2 different switchover modes based on what the consumer's priority is at the moment of the switchover. And the first we just call a switchover. This is a planned switchover event. This is for customers who prioritize consistency. So in a switchover event, you issue a command to your replica region and you say promote yourself to be the primary broker. And then a series of steps happen. First is that your current primary broker, US East 1 in this case, stops accepting connections and drops connections to existing producers and consumers. It then finishes replicating all data that needs to be replicated between itself and what is at the moment the replica broker. And as soon as all the data is synchronized, we know that all the data is moved to the new region, the replica broker promotes itself to primary, opens itself to connections, and begins accepting connections. So in this case, you know that all the data has been migrated before the replica broker promotes itself to primary. Now you're running in US West 2, and you could, in theory, just switch back and forth all the time, and you would have data consistency while you're doing it. And in fact, we see that several customers do just practice switching back and forth all the time to make sure that they're always able to do this. One of the complex challenges in this is, of course, how do you prevent a split brain scenario where you have your primary and replica brokers both believing that they're primary and accepting connections? Because if that happens, you can get yourself into a state where you have irreconcilable differences in the message queues between the 2 brokers that are impossible to reconcile. And if you think about what you use message brokers for, now what you've done is you've sold the same concert ticket to 2 people, and they are not going to have a good time at that concert. So you want to prevent split brain. The 2 brokers need to always know which one is primary, regardless of whether there's network congestion, network challenges, whatever. If any of you are familiar with the 2 generals problem, this is the 2 generals problem. And does anybody remember how you solve the 2 generals problem? But you don't. There's no solution to the 2 generals problem. It's logically impossible. So what do we do? We know that the 2 brokers themselves can't effectively manage split brain. It's not going to be possible in all situations. So the best you can do is you can mitigate it. And this is where we have some advantages running in the cloud. We have a separate process that is dedicated just to managing the state of which broker is primary and which broker is replica. This process runs in multiple regions, vastly more than just the regions that Amazon MQ itself runs in. And it is dedicated to being able to handle effectively 1 bit of information with ultra high consistency, regardless of what is going on with overall networking and trafficking and whatever. And then the brokers, they fail closed, right? If they don't know that they're primary, they assume that they're replica. With this, we basically are able to mitigate, I would say, scenarios where you could have split brain at such a level that if you were to actually encounter it, I think we would have bigger problems going on. It's a system that there's quite a bit of engineering going on and quite a bit going on behind the scenes to make sure that this one piece of state is really carefully managed because it's so important. This is also really important in the case of failover, which is the second switchover mode that we provide. Failover is an unplanned event. This is for customers who value availability over consistency. Failover, you can promote your replica broker even in a case where there's a full network partition between the 2 regions. In a failover scenario, the primary broker the replica broker immediately promotes itself to primary. And we use this widely distributed split brain prevention system to immediately demote the formerly primary broker. Now in this case, there will be messages that have not migrated to the new region. And those messages are retained in the formerly primary region, and you can retrieve them by doing a switch over back. Now here we have to solve problems like, it's entirely possible that in your new primary broker, a consumer will try to acknowledge a message that has not actually been received by the broker. The broker doesn't know about. So there's a lot of state to maintain and a lot of complex things to figure out. The solution to this is not to think real hard about it. Like, there are way too many edge cases to handle just by trying to think through them all. This is where we use multiple rounds of formal validation methods to ensure that in all the cases where you do a failover and you move the state without being able to synchronize the state, no messages are lost, no data is lost, no state is lost, it's all retrievable. All of this, of course, you can do this yourselves with ActiveMQ, the open source product, but I wouldn't recommend it. This is one of the cases where I think working with a cloud provider who has the ability to both deploy at global scale and to work through these issues, this is where I think we add a lot of value to large-scale deployments of message brokers that have these types of requirements. Let me quickly talk about generally what you can experience on the service. We today support 2 versions of ActiveMQ, 5.17, which is the JMS 1.1 focused version. 5.18, which as JB mentioned, is the hybrid version that it helps with migration. By the middle of next year, we'll be supporting ActiveMQ 6 on the service. So if you have a JMS 2.0 workload right now, that's when we'll be able to support that. And you can just easily move your workload over. I mentioned at the beginning of the talk, participating in and contributing to the open source project is a major priority for the team. There are many cases where we learn things about operating ActiveMQ at scale and with a wide variety of workloads. And the priority for us always is to contribute those learnings upstream wherever we can. So for example, in this cross-region data replication, I talked about this feature we call message compression, the sliding window that lets us just avoid sending messages that would have been deleted before they got synchronized. This can be implemented in the data plane in ActiveMQ, and we're working to get that implemented into the broker so that you can do some of this functionality yourselves in a way that we know works really well. And then we are focused, I would say, in our contributions, both in the areas where we learn things and also in the areas that customers ask us for functionality. JMS 2.0 and Jakarta 3.1, these are obvious big ones. Authentication authorization is probably the second most commonly asked for feature. People want to be able to use LDAP, OAuth, other enterprise scale authentication and identity mechanisms, IAM for users who are all in on AWS. And some of these work okay today, and some of them we know we can add better support for to make it really seamless to manage users and access and authentication that way. And then JB will talk a little about some of the ideas around native clustering and sort of a native distributed Apache ActiveMQ, and we're really excited to be involved in development of that. Let me hand it back to JB to talk about what's going on with the project.
Yeah, thanks, Jules. It's great to see ActiveMQ on steroid with Amazon MQ. And also thanks a lot for all the contributions on the ActiveMQ project and community. So this is, I would say, a high-level roadmap about what we plan for ActiveMQ 6 and next. There are not yet not really consensus within the community, but it's the thing we are talking about. There are good chances that's going to happen. The timeline may differ, but that's exactly what's going to happen in ActiveMQ. So the first thing is ActiveMQ. So today we are on ActiveMQ 6.3. What we plan is to release 6.5, probably Q1, Q2 next year. that will have a complete JMS and Jakarta messaging support, because today there are a couple of features from Jakarta messaging we are not yet supporting. I'm thinking about delivery delay, I'm thinking about share consumer. So we need still to do some work on JMS2 support. So that's planned for ActiveMQ 6.5. And then another one going to be 6.6. As Jules said, it's going to be mostly focusing on authentication and authorization. So we want to add, so today the only way for you to support additional authentication and authorization model is by providing your own plugins. So ActiveMQ should provide plugins for you that you just tune or configure to get the authentication you want. So I'm thinking about Auth0, I'm thinking about OIDC, I'm thinking of this kind of backend. So it's basically where we working together, I mean, in the community with the Amazon MQ team to bring new authentication and authorization model in the broker. Another one that, for me, I'm super excited about that. It's going to be in preview, in beta, in 6.7. It's going to be replicated KDB. So just give you some details about what we mean by replicated KDB. Today, if we are using a network broker, you have multiple brokers all together, and so you can have one broker acting as a load balancer, so forwarding messages to the different brokers depending on the load, stuff like that. So you can have clients connecting on any brokers, and they send and consume messages to each broker. If one broker is failing for any reason, all pending messages, persistent messages inside this broker are lost, waiting for the broker to restart. So it means that my client connected to that, they can, using the failover mechanism from ActiveMQ client, they can reconnect to another broker, but they lose all the pending messages. So what we want to do with replicated KDB is to have one broker acting as a kind of main for message and replicate each message to follower brokers. In the case of a failure, any message replicated to another broker going to be available to these brokers, and so the client can still consume and produce it without losing the transaction. So without losing the acknowledge, meaning that we replicate the messages, but also all the acknowledges. So that's the way we are thinking the next step for ActiveMQ, especially in the context of cloud. That would be super great because it means that on Amazon MQ, you will be able to spin off a bunch of brokers. You don't care if they are connected or not. They are just synchronized together using a replication of messages. So that's what we plan for ActiveMQ 6.7. Replicated KDB as a beta first, because we know we have challenges. We already started to implement that. So we know the challenges in terms of performances, in terms of transaction. So that's going to be the first preview in 6.7. And then ActiveMQ 7. We talk about ActiveMQ 6. It's just the beginning, actually, I think. The two big changes, in my opinion, that are going to happen in ActiveMQ 7 first is removing the Spring dependency from the broker. Today, ActiveMQ is powered by Spring. If you take a look on the ActiveMQ XML, it's nothing more than just a Spring Beans XML. It's convenient for us because we don't have to deal with dependency injection. We can namespace handler and schema management is super easy. But it's challenging because it means that we depend on Spring and we depend on all the pro and cons of Spring. So when you have CVs, when you have issues in Spring, we are dependent and we have to release super fast. So what we plan is to replace Spring by something else. I have different ideas that I can share with you, but it's not, as I said, it's still in discussion. It could be a simple SPI interface loader, like we create SPIs and we launch. It's basically what we do with Apache Karaf. So Apache Karaf support ActiveMQ embedded, so we can mimic what we did in Karaf. Or it could be leveraging another kind of framework like Quarkus, for instance. Why not? So that's different options possible there. Replicated KDB is going to be production ready in ActiveMQ 7. The question may be when? Going to be ActiveMQ 7? I don't know. But for me, not before at least the end of 25. Not before that for sure. So if you want to get involved in ActiveMQ, I mean ActiveMQ open source and Apache ActiveMQ community, you can go to activemq.apache.org. You can ping me on Slack or by email or whatever. I will be more than happy to help and mentor you.
Right. Information about the service is available at AWS at this URL, and you can just search for MQ for ActiveMQ. Please feel free to reach out to either of us with questions. If you want to be involved in any way, contribute, we're both happy to talk about that. We also are going to just go hang out over here for some informal Q&A if folks would like to chat with us after the talk. Come find us. We're happy to spend some time answering any and all of your questions. And thank you so much for coming today. Thank you for attending this. It's really great to talk to all of you about this. If I could ask also, please fill out your survey for the session. We really do pay close attention to your feedback in the surveys, and it helps us make sure that we're presenting to you the content that you care about the most. So, thank you, everybody.
Thank you.